So I'm going to go over in this video is working with numerical data and how we can use Geogebra to get out different graphs as well as our descriptive statistics. So when you're at geogebra.org, we want to go to spreadsheet. This is a way that we can input our numerical data. So click on spreadsheet and that'll open up this window here. And what we're going to do is go through our example with those 15 fictional exam scores. So to start out, what you'll want to do is just clicking here at A1, and you're just going to type in your data, hitting enter after each value. So we have these 15 data values in. It's nice to start at A1 because then you can kind of double check your sample size. So we know there's 15 exam scores, and that's where we end right there with that highest score of 100. Then what we want to do is highlight the data. So highlighting the data, you can click and drag, but also what you can do is just click the column title. So if I just click A, it's going to highlight that whole column of data, which is nice and quick. So you want to highlight all of the data. Then what we want to do is go up here to the image that looks like a histogram. So if we click on this, it's going to open up three options. There's one variable analysis, two variable, and then multivariable. Where we're going to be starting off right now is just one variable analysis. Later in the term, we'll look at two variable. But for right now, one variable analysis. So when you click on that, it's going to open up your histogram. So it shows you a histogram. The program automatically sets the bin width, so this doesn't look exactly like what we drew. But what you can do is adjust the bin width and adjust the starting point. So what we could do is if we go to this little gear symbol right here where it says options, you click options, and this very first part, so remember classes is another word for bins, you can set classes manually. So if you click set classes manually, it opens up these two pieces at the top here where it says start, and you can input a number, and width. And to close down this stuff on the right hand side, you can just click the gear symbol again. So if you click options again, it closes down. So let's say we wanted to start at 30 for our minimum value, and then for the width, we want to use that bin width of 10. If we do that, that's going to make our histogram matching what we saw before. So that's how you can adjust your graph for a histogram if you want it to look a specific way. Otherwise, what it will automatically give you is kind of a bin width just determined mathematically based on our data. So right here where it says histogram, there's a drop-down menu. If you click this, you can see there's other graphs we can look at. And here's our box plot, and that should match exactly what we drew by hand there. You can also look at the dot plot, which kind of floats high above the numerical line there. And there's also the stem and leaf plot. One thing that happens with the stem and leaf plot is you might have to do this -1 + 1 to make it look like the one we had. And what you'll notice is they do take out the outlier. They removed it from the set, so it looks a little different than what we made by hand there. But you can double check overall that it's similar to what you do. So this is how we can look at the different graphs. And to get the descriptive statistics out, there's this button in the upper right-hand corner that is Show Statistics, and it's the summation X symbol. If you click on that, it's going to open up this window that has all of our statistics. So the first value is N, which is our sample size. So we have a sample size of 15. Mean, so taking the average of those data values, is 80. These next two pieces relate to standard deviation. You can see the symbol for population standard deviation and S for sample standard deviation. For our data, we always want to use S. Don't use sigma. S, that's 17.7563, that's using the formula that we talked about and applying that formula to our data. The other formula is working with it as if it was population data. Basically what's changing is instead of dividing by degrees of freedom n-1, it's just dividing by n, so it's not taking one away. So never use sigma, always use S for our class for standard deviation. Summation x is just adding up all the values. Summation x squared is just taking each value squared and adding them up. We won't really use those two at all. And then down here is our 5-number summary. Minimum of 31, Q1 of 70, median of 82, Q3 of 94, maximum of 100. So when we have large data sets, this is going to be a very valuable tool. Instead of calculating things by hand, just use technology to get the values out. But you do know how to find them if technology fails you. But especially when it comes to calculating standard deviation, we just want to get that value from here. So I highly recommend Geogebra for carrying this out because you get a clear view of your data itself, the statistics coming from your data, as well as a nice visual to go with it.